Hi class. Today, as I promised, I'm making a right triangle trigonometry review video. So that's what you're going to get today. I'm just going to go through the review so that everyone understands what's going on before they take a test. All right, first question. Find the values of the 6 trig functions for angle theta. Give answers in simplest form. So what you would do here is you have a right triangle, you know 2 of the 3 sides. In order to get the third side, we have to use Pythagorean's theorem. And if it's the hypotenuse that you don't know, you only know the 2 legs, then you can just set it up as the square root of 7 squared plus 24 squared, sum of the legs squared. All right, and then it's not too bad. You come up with that third side that way, place it right in the calculator. That's why it's not so bad. So you can just plug in square root and then 7 squared plus 24 squared. And make sure it's all under the radical. And then hit enter. You get 25. So that's equal to 25, and that is your hypotenuse. So once you have the hypotenuse, then you can find all the 6 functions values. So sine of theta, here's theta right here. Sine of theta, sine remember is opposite over hypotenuse, so 24 over 25. And then cosecant is always its reciprocal, 25 over 24. All right, and that's pretty easy to come up with once you've got the sine. Now the cosine is adjacent over hypotenuse. Remember, adjacent is 7. It's the leg that runs right into the angle. So 7 over the hypotenuse, 25. And then the secant is its reciprocal, which would be 25 over 7. And then the tangent is opposite over adjacent. So opposite over adjacent, 24 over 7 is tangent. And then the cotangent would be the reciprocal, 7 over 24. All right. One quick thing I remember that I don't think I said in the videos, SOHCAHTOA is something that people use, an acronym people use all the time. Sine theta equals opposite over hypotenuse is what the SO stands for. Cosine theta equals adjacent over hypotenuse is what CA stands for. Remember, the first one is the top, so A over H. And then TOA, tangent, theta is equal to opposite over adjacent. And that little acronym could be used to help you when you come up with your 6 trig functions for any angle. All right, number 2, find the values of the 6 trig functions for angle theta and give answers in simplest form. So here you have angle theta. And again, you're going to need in order to do all of the 6 functions, you're going to need this third side. So the first thing I would do is set up Pythagorean's theorem. If you recall, if you have the hypotenuse and a leg and you're looking for the leg, you take the hypotenuse squared under the radical and subtract the leg squared. All right, under the radical. So 2 of the legs, then you square and sum them under the radical. A hypotenuse and a leg, you subtract and square them under the radical. That's always an easy way to remember. Or you can just set up Pythagorean theorem and solve and get there that way. All right, so for on the calculator, you're just going to type in your radical, 21 squared minus 18 squared. And hit enter. That one's going to be a radical. And do it on the other calculator. So I don't have to, because you want it in simplest radical form. So square root 21 squared. Square root 21 squared. I don't know if this is, I don't use this calculator enough to know if this is going to give me what I want. Oh, it did. All right, so 21 squared minus 18 squared is 3 radical 13. And that's simplified, of course, which is what we want. All right, so sine theta. So right here's the angle that we're in question. So sine is opposite over hypotenuse. So 18 over 21, opposite over hypotenuse, is 18 over 21. Now, I like to use my space here because I know 18 and 21 are both divisible by 3. So that makes 6 over 7, and that's what sine is. And then you can just flip it, 7, 6. You can't flip it so well when you have the radical involved, but because this didn't involve the radical, it was easy just to flip it. Once we get the radical, it's a little tricky. A little more tricky. So cosine theta, cosine is the leg adjacent, which runs right into the angle. It's this leg, 3 radical 13 over 21. So again, use your space, 3 radical 13 over hypotenuse. Cosine is adjacent over hypotenuse. Again, your 3 and 21 divide out and you get radical 13 over 7. Now you can flip it, but you have a little bit of work to do for secant, because once you flip it, so the secant's going to be 7 over radical 13 flipped. But you can't leave the radical 13 on the denominator, so you have to rationalize by timesing by radical 13 over radical 13. So 7 radical 13 over 13 is what you get. All right. And then tangent theta is going to be opposite over adjacent. So over A, that's your tangent on the TOA, opposite over adjacent. So opposite is 18, adjacent is 3 radical 13, and the 3 and the 9 factor out of 3 are simplified to 6 over radical 13. 3 divided into 3 is 1, and 3 into 18 is 6. And then you have to rationalize by multiplying both top and bottom by radical 13, which gives you 6 radical 13 over 13. Now this is one of those that you can't just flip. It's been rationalized, so it's a little more involved. At this stage right here, before you rationalize, is when you want to flip. So at that stage, you're going to flip it, and it'll be radical 13 over 6. All right? Because it's not necessary for you to rationalize. And in fact, rationalizing for the tangent was necessary, but if you flip it there, then all of a sudden you have to multiply by radical 13 over radical 13 again, because it becomes unrationalized. All right, last two give you a trig function. Tangent theta is 2/7, and it asks you to find the remaining trig functions. Now, when you're given tangent theta is 2/7, then you have to set up a right triangle with a theta and put your sides in, and then find the third side. So a couple of steps involved there. So you draw your right triangle, put in your theta there. Tangent is opposite over adjacent. So opposite needs to be 2. Opposite is 2. And adjacent, one that runs right into it, is 7. So those are your two sides that you have. You have the two legs, you don't have the hypotenuse. So in order to find the hypotenuse, you're going to take the square root of the square of the legs sum added together. So again, I'm going to use this calculator because it rationalizes and everything for me. It's so nice. So square root of 2 squared plus 7 squared. And that is radical 53. All right. And it's hard to find the spot for it to actually show radical 53. So your third side, your hypotenuse, is radical 53. All right. Now that I have those, we can again move over. We know the cotangent real quick because it's going to be the reciprocal of the tangent. And we don't really need a triangle for that. But the rest we do because we needed the hypotenuse. So the sine of theta is going to be opposite over hypotenuse. Sine is opposite over hypotenuse with our SOHCAHTOA. So 2 over radical 53. And again, we can't leave a radical in the denominator, so we need to rationalize. So we get 2 radical 53 over 53 for sine. Now the cosecant is flipped, but since it's been rationalized, we don't want to flip it. We want to flip it at this stage before the rationalization, which is radical 53 over 2. And that takes care of all the radicals, everything on the denominator. Now the cosine is going to be 7 adjacent over hypotenuse, so 7 over radical 53. But we can't leave 7 over radical 53. We have to multiply by radical 53 over radical 53, which is 7 radical 53 over 53 is cosine. 7 radical 53 over 53. And then we need to flip it, but we don't want to flip it rationalized. We want to flip it right there, which is radical 53 over 7. That's how you do number 3. All right, number 4. If secant theta is 4 radical 2 over 3, then find the remaining functions. Now, secant might be a little more difficult for us to figure out. Again, draw your right triangle with an angle. You know that secant is the reciprocal of cosine. So the cosine must be 3 over 4 radical 2, the reciprocal. So cosine is adjacent over hypotenuse, so 3 is adjacent and 4 radical 2 is hypotenuse. And then we have to find the third side. So in order to come up with the third side, we take the square root. I'm going to write it under here so I can use my space. So the square root of the hypotenuse, 4 radical 2 squared, minus the leg squared. Because we have hypotenuse and a leg. Now, again, we're going to just use our calculator, square root, in parentheses, 4 radical 2, arrow out, quantity squared. We have to make sure we plug it in just like we see it, minus 3 squared under the radical, all right? And that is radical 23. So radical 23 is that third side. Okay, now if that's radical 23, then we can use our functions. Now, the cosine, I already flipped it. However, it's not rationalized, so I must rationalize it. Let's start with that because I already have it written down. 3 radical 2 over 4 times. Now, this radical 2 times radical 2 is just 2. And I have a 4 times that, which is 2. So 4 times 2 is going to be 3 radical 2 over 8. All right? That one was kind of a tricky one, so we started with it. Now we'll do sine theta. Here's our theta. Sine is going to be opposite over hypotenuse. So opposite over hypotenuse, radical 23 over 4 radical 2 is sine. Again, you can't leave the radical 2 in the denominator, so multiply by radical 2 over radical 2, and you get radical 46 over 4 times, again, radical 2 times radical 2 is 2. So we have 4 times 2, just like we did with the cosine. That's radical 46 over 8 for sine. That's awesome. 46 is 2 times 23. It has no, it doesn't have a perfect square factor, so it's already simplified. I always think of that. All right, now this hasn't been well, I guess right here. No, wait, cosecant. This is the sine, right? Opposite over hypotenuse, yep. So right here, before we rationalize is when we're going to want to flip it. So it's going to be 4 radical 2 over radical 23 to find the reciprocal. All right, so you're going to multiply by radical 23 over radical 23. That makes 4 radical 46 over 23. That is crazy. All right, tangent. If we do tangent, it's going to be opposite over adjacent. So that one's just radical 23 over 3. And then the cotangent is flipped over, so 3 over radical 23, which isn't rationalized. So we'll have to multiply by radical 23 over radical 23, which is 3 radical 23 over 23. All right, so that's our first video. And I'm going to stop there, and then we'll do the second half on the second video.